All right, so I don't know why I said that really loud and it echoes in this room. Okay, I've got this equation and you should be thinking, all right, this to me feels like a box problem because I've got x's in two positions and they've got the x squared followed by an x situation. So you've got a 2x squared in there, a minus 7. You're thinking 2x and x. I'm thinking that too. Two numbers that multiply to 7. My first thought is 7 and 1. One of those has to be a negative, so I'm just going to put it with a minus sign. If it doesn't work out, I'll keep trying. 7 times 2x is 14x minus 1x. 14 minus 1 is 13x, not negative 3. So maybe I'll try moving the 7 and the negative 1. So I'll put 7 here and negative 1 here. Negative 1 times 2 is negative 2x. That's a 7x. Combine these two together. 7x minus 2x is 5x. That's not the same as this. So spoiler alert, you're going to keep trying to do this over and over and over again, and you're going to realize that this box does not work. And your backup plan should be the crazy thing that we learned on Monday, something known as the quadratic, which again is the unit that we're in, the quadratic formula. So the quadratic formula is your way to solve equations when the box problems don't get you to work out. All right, so I call it the box gone bad problems. Basically, you try to do your box, it's not working out, so you go to the quadratic formula, which again, I can share with you like where this came from. If you ever want to see me and we go over how to do this problem, this didn't just magic itself. It's actually a really intuitive, beautiful, and easy understanding. We just talk about it in Algebra 2. So we're going to use this formula, and you're thinking, okay, it looks a little crazy, but we're going to just make sure that we take all the letters and turn them into numbers. So A is going to get replaced by a number, B is going to get replaced by a number, and C is going to get replaced by a number. So A is going to be the number in front of x squared. So whatever's chilling with x squared, that's what A is. Whatever is hanging out with x, that's B. And whatever is with no letters, that's going to be your C. So if we just go in that order, A is the thing in front of x squared. So A is 2. B is the number that's in front of x, so that's going to be negative 3. And C is going to be the number that's all by itself, which is negative 7. So we've got our A, our B, our C. I always write them down like that. And then I'm going to substitute. So if you like read the formula or anywhere that it's like spoken, so if you like listen to a song to help you memorize it, not that you need to, this is always pronounced as the opposite of B. Whatever your B value is, you're going to make it opposite. So my B value is negative 3. So we're going to switch that negative 3 to a positive 3. And then I'm going to copy exactly what I see next. So what I see is that plus minus, and then I see that square root symbol. And then I'm going to start filling things in. So the first thing I see under there is B. So my B is negative 3, which I'm always going to put in a parenthesis. Every time I replace something, I'm going to put a parenthesis over it. So I'm going to put a parenthesis here, 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 and here. I don't do that to the opposite of B because it's just one number all by itself. Then what I see after the B is a square, so I'm going to write square. Then I see a minus sign and a 4. It's always 4. Then I see an A. Again, I'm going to put a parenthesis every time I'm making a replacement. A is 2. Then I see a C, so I find C, which is negative 7. And then I put a giant fraction bar over all of that, and then I write 2 because that's what's underneath here. And 2A, and again, A was 2, and ta-da. So now we've taken this crazy formula with a whole bunch of letters in it, and now it's all numbers. So yes, it still looks crazy, but at least we're not working with 3 different variables. We're just working with numbers. And now your goal should be to get one number here, one number underneath the radical, and one number downstairs. So one number on the outside, one number on the inside, and one number downstairs. So the way that we do this is easy to simple. Easy to more challenging. And so I'm going to start with the 3 out in front, and it's already done for us. So the lovely thing about that 3 by itself is that it's already on its own. And then I'm going to move downstairs to 2 and 2. 2 times 2 is 4, so 4, right? Not so bad. And then I'm going to take all the stuff that I wrote underneath the radical, And I'm going to write it exactly the way I see it, not with the square root symbol, just the numbers. So -3 squared with a -4 with a parenthesis 2 in it. Okay, a 2 followed by a -7, and that's going to be 65. So, excuse me, one number on the outside, one number on the inside, and one number downstairs. And so the way I got this number really was to just take that whole phrase that's underneath that radical and put it into Desmos, and that's just going to get you your one number. And now remember, most of these equations have two answers, right? Like when we do a box problem, we do the box problem and then we use the two parentheses on the outside to split and solve our two answers. We still have two answers here too. If you try to take that plus minus and you put that into Desmos, it's going to freak out. So what we're going to do is we're going to write two different equations from that. We're going to separate the 3 plus the square root of 65 over 4. And then we're going to do the same exact thing on the other side. 3 minus the square root of 65 over 4. And those are our two answers. So if you want to be really fancy, this is answer number 1. And this is answer number 2. And both of them are correct answers, just like when we're solving a split and solve problem. If we have x plus 4 and x plus 2 from the box, let's say, from the two sides, and you separate them, you're going to have one pretty answer from that parenthesis, and you're going to have one really nice answer from this parenthesis. But as you know, this quadratic formula was from a box that didn't work out. So instead of having two pretty nice numbers, like whole numbers, like we did here in this little example, you're going to get really messy numbers. And that's what this is, your two messy numbers. And just to show you how messy they are, we can take that equation that we just got the same way that you see it. So I'm going to write 3 divided by 4. That's the first half of that. And then I'm going to go back up to the top of that and put this plus the square root of 65. So that's how messy that decimal is. So your first answer is 2.765 if you want to turn it into a decimal. The second answer, I'm going to just switch that plus sign to a minus sign, and you're going to get negative 1.265. And there are my two answers, my one positive answer and my one negative answer. And we just get that from using that crazy messy formula where we replace the A, B, and C from the numbers from the equation and then just put that whole thing in the calculator. And if you really want to trust that I'm right, if I take that equation, remember when we set things equal to 0, we're finding when the parabola hits the ground. We're essentially just looking for the x-intercepts. So if you look for the x-intercepts, there's the negative 1.265, and there's the 2.765. So if you were able to use Desmos, you could just plot the whole thing on the calculator and just find where you've got your x-intercepts. But you can't do that on the test, and you can't, and they didn't have Desmos 100 years ago or 200 years ago, so they all had to do these crazy things all by hand. And there used to be tables where you'd have to look up what the square root of 65 was to get your answers this way. But, so you can use your calculator a little bit, just not, I guess, for the whole thing. All right, I hope that helps.